take off your shoes. Stand on a flat surface. Look down at your feet. Specifically, look at the space between your big toe and your second toe. Is there a gap? Can you see daylight between them without spreading them intentionally? Does your big toe angle slightly away from the others, creating a natural space that has been there as long as you can remember? If the answer is yes, your feet are showing you something that most people in the modern world have lost. A structural feature that was standard in the human foot for over 200,000 years, that every one of your ancestors had, and that the modern shoe has been systematically eliminating from the human body for the last 10,000 years. That gap is not a quirk. It is not a defect. It is not a sign that your feet are shaped wrong. It is the original architecture, the factory setting, the way the human foot was designed to function before shoes compressed it into a shape that serves fashion instead of biomechanics. Researchers who study habitually barefoot populations, communities that have never worn restrictive footwear, find the gap in virtually every individual. It is the default. The populations that have lost the gap are the ones who have been wearing shoes for the most generations, the shod populations, the populations whose feet were reshaped over centuries of enclosure into a form that the foot was never designed to hold. If you have the gap, your feet retain something ancient. If you do not, your feet were changed by something modern. Both stories are written in the bones, tendons, and genetic predispositions that determine whether your big toe separates from your second, or whether it has been pushed against it by 10,000 years of leather, rubber, and laces. Subscribe. Because the gap between your toes is a window into how your ancestors walked, where they walked, and whether they walked in shoes. The human foot has 26 bones, 33 joints, and over 100 muscles, tendons, and ligaments. It is one of the most complex mechanical structures in the body, and for roughly 99.5% of human existence, it operated without a shoe. The earliest confirmed footwear dates to approximately 8,000 to 10,000 years ago. Woven sandals from Fort Rock Cave in Oregon, animal hide wrappings from European cave sites. Before that, for roughly 290,000 years of anatomically modern human existence, every step was barefoot. Archaeological evidence suggests that something changed in the human foot roughly 30,000 to 40,000 years ago. The toe bones, the phalanges, of later human populations became thinner and more gracile than those of earlier humans. Anthropologist Eric Trinkhaus at Washington University proposed in a landmark study that this gracilization was a direct result of habitual footwear use. Shoes redistributed the forces on the foot, reducing the mechanical stress on the toes, which caused the bones to become lighter over generations. But the structural change that matters most for your toe gap is not about bone thickness, it is about alignment. The modern shoe has a toe box. The toe box is the front portion of the shoe that encloses the toes. In virtually all conventional footwear, the toe box is narrower than the natural splay of an unshod foot. It compresses the toes together, pushing the big toe toward the second toe and the fifth toe toward the fourth. Wear a narrow shoe for a day and you feel pressure. Wear one for a year and the soft tissue adapts. Wear restrictive footwear for a lifetime and the bones themselves remodel. Wear restrictive footwear for 50 generations and the population's foot morphology shifts. The toe box did not just change the shape of individual feet. Over centuries, it changed the shape of the human foot as a species. Comparative studies between habitually barefoot populations and habitually shod populations show consistent differences. Barefoot populations have wider feet at the toe line, more splayed metatarsal arrangement, greater toe mobility and dexterity. The big toe maintains its natural abducted position, angled slightly away from the second toe, creating the gap. Shod populations have narrower forefeet, compressed metatarsals, reduced toe mobility, and the big toe pushed medially toward the second toe, often to the point of contact. The gap closes, the hallux, the big toe, drifts toward its neighbor, and in extreme cases, the joint deforms entirely, producing what medicine calls hallux valgus and the rest of the world calls a bunion. A bunion is not a disease. It is the end point of a process that begins with a narrow shoe, continues through a lifetime of compression, and sometimes carries forward through generations of genetic predisposition toward a foot shape that the shoe created. The gap between your toes is the opposite of a bunion. It is the foot in its natural state, unsqueezed, uncompressed. Still shaped the way it was shaped when your ancestors walked without shoes. Toe spacing is partly genetic. The width of your forefoot, the angle of your hallux, and the natural splay of your metatarsals are influenced by the same skeletal development genes that control the rest of your bone structure. If your parents had wide feet with separated toes, your probability of having the same feature is elevated. The key gene involved in toe development is TBX4, a transcription factor that controls limb patterning during fetal development. TBX4 is essential for leg and foot formation. Mutations in TBX4 cause a condition called small patella syndrome, which includes a characteristic wide gap between the first and second toes as one of its diagnostic features. The gene does not just build toes, it determines their position, spacing, and alignment, but TBX4 is the extreme case. For most people, the width of the toe gap is determined by a combination of genetic predisposition and environmental influence. The genetic component sets the range. The environment, specifically footwear, determines where within that range your foot develops. A child who grows up barefoot will develop the full toe splay that their genetics allow. A child who grows up in rigid shoes will develop a compressed forefoot regardless of their genetic potential for wider spacing. The shoe overrides the gene. But the gene does not disappear. It sits in the genome waiting. If the next generation goes barefoot, the splay returns. This is why the gap varies so dramatically across populations. Communities in sub-Saharan Africa, South and Southeast Asia, and the Pacific Islands that have traditionally gone barefoot or worn open sandals maintain wider toe spacing than populations in Europe, East Asia, and North America that have worn enclosed footwear for centuries. The difference is not racial, it is historical. It tracks with footwear culture, not with ethnicity. A Japanese population that has worn narrow tabi shoes for centuries shows narrower forefoot morphology than a Polynesian population that has worn open sandals or gone barefoot. Both are East Asian adjacent populations. The feet are different because the shoes were different. Your toe gap, or the absence of it, is a record of your ancestors' relationship with footwear. Generations of shoes pushed the toes together. Generations of barefoot walking kept them apart. The genetic potential for the gap exists in every human genome. Whether it is expressed depends on what you and your ancestors wore on your feet. If you have made it this far, subscribe. The next chapter goes back further, much further, to the foot that your foot used to be before it was a foot at all. The gap between your big toe and your second toe is not new. It is ancient, and by ancient, the timeline being discussed here is not thousands of years, it is millions. Every non-human primate on Earth has a divergent big toe. In chimpanzees, gorillas, and orangutans, the big toe is opposable. It functions like a thumb, it grips branches, it wraps around limbs. The gap between the big toe and the other toes is not a gap in primates, it is a joint, a functional, load-bearing, grasping structure designed for life in the trees. When human ancestors transitioned from arboreal life to bipedal walking, roughly 4 to 6 million years ago, the big toe changed. It moved from an opposable position, angled away from the foot, to an adducted position, aligned with the other toes. The grasping function was traded for stability. A foot that could grip a branch became a foot that could push off the ground. But the transition was not total. The big toe moved toward the other toes, but it did not fuse with them. The metatarsal joint retained more mobility than the other toe joints. The gap narrowed, but it did not close completely. In the natural, unshod human foot, the big toe maintains a slight abduction, a small angle outward from the second toe. That is the evolutionary residue of the grasping foot. Your toe gap is a remnant of 60 million years of primate evolution. The grasping toe that your tree-dwelling ancestors used to survive in the canopy was repurposed for walking, but the architecture was not completely redesigned. The gap is the trace, the memory of a function that your foot abandoned millions of years ago but never fully erased. The Laetoli footprints in Tanzania, made by early hominins roughly 3.6 million years ago in volcanic ash, show a foot that is strikingly human in shape but with a slightly more divergent big toe than modern humans typically display. The gap was wider. The big toe was still transitioning from grasping to walking. 3.6 million years ago, your ancestors' toe gap was bigger than yours. Every generation since then has been closing it slightly. And then shoes arrived and accelerated the closure. If you have the gap, your foot is closer to the Laetoli footprint than the foot of someone whose toe has been pushed flat against its neighbor by 10,000 years of leather toe boxes. Your foot is more natural. In the purely biomechanical sense of the word, your foot is more human. Not every culture compressed the foot. Some cultures recognized the gap as essential and built their footwear around it rather than against it. Japan developed the geta and zori, wooden and woven platform sandals held to the foot by a thong strap that passes between the big toe and the second toe. The design requires the gap. A foot without toe separation cannot wear a traditional Japanese sandal. The tabi sock, a split-toed sock designed to be worn with these sandals, maintains the separation between the big toe and the other toes, effectively training the foot to preserve its natural splay. The result is visible in population studies. Japanese individuals who regularly wear traditional sandals maintain wider first toe gaps than those who wear exclusively Western-style shoes. The footwear preserves the anatomy. The anatomy enables the footwear, a feedback loop between culture and biology that has been running for centuries. Across South and Southeast Asia, open sandals and barefoot walking have been the norm for most of history. The chapels of India, the flip-flops of Thailand and the Philippines, the sandals of Indonesia, all use the thong between toes design that preserves the gap. Populations in these regions consistently show wider forefoot morphology and greater toe splay than populations in regions that adopted enclosed European-style footwear. In Africa, barefoot walking remains common in rural communities across the continent. Studies of habitually barefoot populations in Kenya, South Africa, and Ethiopia show foot morphology that includes wider forefeet, greater toe mobility, stronger intrinsic foot muscles, and dramatically lower rates of bunions, hammertoes, and other forefoot deformities. The numbers are striking. Bunion prevalence in habitually shod Western populations ranges from 23 to 36%. In habitually barefoot populations, it is close to zero. Bunions are not a genetic disease. They are a shoe disease. And the gap between your toes, if you have one, is the evidence that your foot has resisted, at least partially, the deformity that shoes impose. And then there is the modern barefoot movement. Over the past 2 decades, a growing community of people in Western countries has adopted barefoot walking or minimalist footwear. Toe spacers, devices worn between the toes to restore the natural splay, are now a multi-million-dollar market. People are paying money to recreate the gap that their ancestors had for free. The industry exists because the gap was taken. Shoes compressed the forefoot. The big toe drifted toward the second toe. The natural space enclosed. And now, in the 21st century, people are buying silicone inserts to reverse a process that 10,000 years of footwear created. The gap is being sold back to the population that lost it. And the populations that never lost it are watching with the quiet amusement of people who never understood why anyone would put their feet in a box in the first place. So look at your feet one more time. If you have a natural gap between your big toe and your second toe, a space that exists without you deliberately spreading your toes, your foot has retained the original human architecture. The splay that every barefoot population maintains, the remnant of a grasping toe that your primate ancestors used 60 million years ago, the biomechanical alignment that 290,000 years of barefoot walking preserved, and that 10,000 years of shoes began to erase. Your gap may be genetic, inherited from parents whose foot structure naturally resists compression. It may be environmental, the result of growing up in flexible or open footwear that allowed your toes to develop without constraint. It may be both, the gene and the environment working together to preserve something that the modern world is actively trying to eliminate. If you do not have the gap, if your big toe presses against your second toe or angles toward it, your foot has been reshaped, not by disease, by shoes, by generations of footwear that prioritized appearance over architecture. The compression is reversible in many cases, which is why toe spacers, barefoot shoes, and wide toe box footwear are growing markets. The foot can partially recover what the shoe took, but the recovery is slow, and the foot remembers what it was shaped into. The gap is not about ancestry in the way that eye color or finger ratio are about ancestry. It is about something older, something that predates ethnicity, predates migration, predates every border and every civilization. It is about the relationship between your body and the ground it walks on, a relationship that was direct, unmediated, and uncompressed for 99.5% of human history. Your feet are the most used and least examined part of your body. You walk on them every day. You put them in boxes every morning. You take them out every night. And the gap, or the absence of it, has been telling a story about how your ancestors moved through the world that you have been too far from the ground to hear. The ground is still there. The gap is still possible. And 60 million years of primate evolution say that your big toe was never supposed to touch your second. The shoe disagrees. Your DNA does not. 60 million years of primate evolution, 290,000 years of barefoot walking, 10,000 years of shoes, and a gap between your toes that is either still there, proving your foot retained its original architecture, or gone, proving the shoe won. Barefoot populations have it. Shod populations lost it. The toe spacer industry is now selling it back for $15 a pair. And the Laetoli footprints, pressed into volcanic ash 3.6 million years ago, show a gap wider than any modern human foot still carries. Drop a comment. Do you have the gap? Has it always been there? Do your parents have it? And if you wear shoes every day, try standing barefoot right now and see if your big toe remembers where it is supposed to be. Subscribe for more. Share this with someone and make them take off their shoes. We will see you next time.